Hi class, we're on to the last lesson of chapter 6. We're talking about parabolas. In the whole chapter this time we're talking about sideways parabolas. So ones that open up to the right or ones that open up to the left. Every other parabola that we've talked about so far in this section has been opening up or down. So let's see the differences and a lot of the similarities between them. The left side here is what we've been talking about the entire lesson. Okay, so now instead of a y equals equation, it's going to be an x equals equation when it opens up right and left. The a value is going to do the same thing. It stays in the same spot. Notice where your vertex is. Your x coordinate is at h and your y coordinate is at k. Notice how with parabolas that open left and right, which is what we're talking about today, they change places. So h and k is where your vertex is still, but the h this time is going to be outside the parentheses. The k is the value that is inside the parentheses. So now your axis of symmetry, when we have a parabola that goes up or down, your parabola or your axis of symmetry is a vertical line. So that's an x equals equation, and it's x equals the x coordinate, which is h. However, when we talk about sideways parabolas, now we're talking about parabolas that look like this. So the axis of symmetry, what cuts the parabola in half? It's a horizontal line, which is a y equals line, and it's going to be y equals the y coordinate of the vertex, which is y equals k. So there's another difference. And then we have this: if a is positive, the parabola opens up. If a is negative, the parabola opens down. So now when we talk about today's lesson, when a is positive, the graph opens up to the right. When a is negative, the graph opens up to the left. So there's a lot of similarities, but there's a lot of differences that we really need to keep straight as we do these problems. Let's talk about the first problem. It's already in vertex form, which is really nice. So your vertex is at hk. H is outside the parenthesis this time, so the h value is 1, and the k value is the opposite of what's in here. It's at a positive 2. So there's where your vertex is. Your axis of symmetry, instead of an x equals line, it's a y equals the y coordinate, or the line y equals 2. So let's draw in your axis of symmetry with this dotted line. Y equals 2 is your axis of symmetry. So your parabola should be symmetrical about that line. Your a value here is a negative 1. So if you know it's negative, you know it's going to open up to the left. So your vertex, let's plot it, is right 1 up 2. There's where your vertex is. We already graphed our axis of symmetry. Now class, don't draw this yet, okay? Just watch. If your a value is 1 on a graph that opens up, you went up 1, right 1, up 3, right 1. Your patterns are going to be the same for a. However, instead of having this look to it, it's now going to open up to the left. So that means that we're still going to have our 1 and 3, so on and so forth, except it's going to look like this. Now you can start drawing with me. It's right 1, up 1, right 1, 2, 3, up 1. Left 1, down 1, left 1, 2, 3, down 1. And we have these 5 points that represent your parabola. So that's what we have on this one. If you ever want to check your work, class, you can put any one of these 5 points into your equation right here, and the left side should equal the right side. We'll just try this one for example. This point is negative 1, 2, 3, 0. So at negative 3, 0, we're saying that this point lies on the parabola. So your x-coordinate is a negative 3. Does that equal a negative 1 times 0 minus 2 quantity squared plus 1? Well, 0 minus 2 is a negative 2. A negative 2 squared is a negative 4. Sorry, a negative 2 squared. A negative 2 times negative 2 is a positive 4. And a positive 4 times a negative 1 is a negative 4. Negative 4 plus 1 is a negative 3. So a negative 3 equals a negative 3. It checks. So that's what we have for problem number 1. Let's practice problem number 2. Slightly more difficult. Your vertex is at hk. So here's your h value. It's at a negative 2. Your k value is right here. It's at a negative 4. So negative 2, negative 4, this is where your vertex lies. Your axis of symmetry is y equals the y coordinate, so y equals a negative 4. And then your a value is 1/3, which is a little bit tricky. It tells you that it opens up to the right. The reason for that is because a is positive. So let's look what we got. Y equals negative 4 is your axis of symmetry. So your parabola is symmetrical about that line. Your vertex is left 2, down 4. Left 1, 2, down 1, 2, 3, 4. Now your a value is 1/3, and this does make it tricky. So pay very close attention to what I'm going to say here. We don't have a pattern for a when it involves 1/3, so we're just going to plot a few points. Make sure that they're convenient points, though. Those are the easiest ones to graph. So I know that whatever I do right here, class, I'm going to have to multiply it by 1/3 in the very next step. And multiplying by 1/3 is the same thing as dividing by 3. So I know that it opens up to the right. So let's pick a y value that is bigger than the y value of a negative 1, 2, 3, 4. Bigger than a negative 4. So let's try the y value of maybe a negative 3. A negative 3 plus 4 is 1, and 1 squared is 1. But then if you were to divide that by 3, it doesn't work out well. So we're not going to try a negative 3. Let's try maybe a negative 2. A negative 2 plus 4 is 2, and 2 squared is 4. But then 4 times 1/3, once again we get a messy fraction, so let's not use that. Let's use a negative 1 maybe. A negative 1 plus 4 is 3, and 3 squared, I think we got something here. 3 squared is 9. So now we have 9 times 1/3 minus 2. So you see how this is much more of a convenient point? 1/3 of 9, or 9 divided by 3, is 3. So this whole thing becomes 3, and 3 minus 2 is 1. So I know that we have another ordered pair here. When I put in a y coordinate of a negative 1, when I put a negative 1 into my y coordinate, I got an x value of 1. So another point on my parabola is right 1, down 1. And because parabolas are always symmetrical, I know that if I go up 1, 2, 3, and over 1, 2, 3, I can do the same thing going down 1, 2, 3, and over 1, 2, 3. So another point on my parabola is right there. Hopefully that makes sense to you. Let's try one more to practice. We want to get a convenient xy ordered pair, which means a nice integer coordinate. So if we also, as you can see, we need to divide by 3. So if I had a y value of 2, 2 plus 4 is 6, and then 6 squared is 36. So it's 1/3 of 36 minus 2. 1/3 of 36 is 12, and 12 minus 2 is 10. So I just put in another point. Another point is when I put in a y value of 2, I got an x coordinate of 10. So we could put that on there. At right, oopsie, we put in a y value of 2, and we got an x coordinate of 10. So 10, 2. So let's go right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 2. Somewhere right in there, and then obviously the same point on the other side. So here is what our parabola would then look like. Alright, let's do 2 more problems. This time we might have to complete the square because it's not in vertex form. So we want to get this time our x's and constants to one side and our y squared and y's to the other side. So let's add a y squared right here. Keep my 4x's on the left, and we'll subtract 13. So we have 4x minus 13 on the left. That equals a positive y squared plus 2y on the right. You're ready to complete your square once you have y squared and y to one side and the x's and constants to the other side. So let's fill in our blank. 4x minus 13 plus a blank. That equals y squared plus 2y plus a blank. In for your blank is b divided by 2, that squared. So 2 divided by 2, 2 divided by 2 is 1, and 1 squared is 1. So if you add 1 on the right, you got to add 1 onto the left. So we end up getting this then. 4x minus 12, because a negative 13 plus 1 is negative 12, that equals a binomial squared. That binomial is going to have a positive sign in it, and it's going to be y plus 1. It's going to be b divided by 2 for that second term in the binomial. We're going to add 12, so 4x equals the quantity y plus 1 quantity squared plus 12. And then finally, to get x all by itself, let's divide both sides here by 4. So all this I'm going to put over here. We now have x all by itself. That equals this term divided by 4 could be said as 1/4 times y plus 1 quantity squared. So your a value is 1/4, and then your second term, 12 divided by 4, is a positive 3. There you have it in vertex form. Now we can easily pick out the vertex. The vertex is at h, which is 3, and k, which is at a negative 1. 3, negative 1 is your vertex for this one. So that means your axis of symmetry, it opens up to the right, so it's going to be a y equals, and that's y equals the y coordinate, which y equals a negative 1. What is the direction of opening? It's going to open up to the right. Why is this going to open up to the right? Because your a value is positive. It's a positive 1/4. Okay, why don't you guys pause the video and try number 4 on your own. Okay, keep x where it is. So you're going to get x plus 1 off to the left because you added 1 to both sides. And then you're going to get your y squared off to the right. So subtract it. You have a negative y squared plus 4y. So, you know, when the parabolas open up and down, you want a y equals equation. When parabolas open up right and left, you want an x equals equation. So get x to one side with the constant, everything else to the other. You can't complete the square yet because you have a negative in front of your squared value. So you have to factor out that negative 1. So it's a negative 1 times y squared minus 4y. That's what equals x plus 1. Now you're ready to complete your square. So we have x plus 1 plus blank. That equals a negative 1 times the quantity y squared minus 4y plus blank. In the blank is b divided by 2 squared. 4 divided by 2 is 2, and 2 squared is 4. So if we add 4, we're actually adding negative 4. So negative 4 goes over here. So now you should get x minus 3 on the left. That equals a negative 1 multiplied by a binomial squared. That binomial is going to have a subtraction sign in the middle, and it's going to be y minus b divided by 2, or y minus 2. So lastly, in vertex form, you're going to add 3 to both sides. So you get x equals a negative 1 multiplied by y minus 2 quantity squared plus 3. Interpreting our information now, our vertex is at h, which is 3, and k, which is at a positive 2. 3, 2 is your vertex. Your axis of symmetry is a y equals line, a y equals the y coordinate, which is y equals 2. And lastly, your direction of opening, because your a value is negative, it is going to open up to the left. So that is how you do problem number 4. Let me know if you have any questions when you get to class tomorrow on Sideways Parabolas.